Hello everyone, welcome to DevStandup episode 31. And today our guest speaker is Umut Benzer. Umut is an acting independent engineer helping companies with their success. He has previously worked at OAuth. And today he's going to talk about OAuth and OIDC understanding. He is going to explore actually what's going to happen when you click this sign in with Google or that kind of buttons. Without further ado, I would like to pass the microphone to Umut and he could kick off the session. So Umut, here you are.
Thank you so much, Anur, and hello everyone. So today I have one thing that I want to let you everyone know that you have an understanding of what happens under the hood when you click that button. And let me share my screen and start showing some stuff immediately. Okay, let's see. Okay, so some crazy feedback and adjusting things. Okay, I think we are good now. Okay, so first, what I want to show is this. You are in a website. In this case, you are in ChatGPT. You press this login button and you see these options. You clicked one of them. In this case, I click continue with Google and some stuff happens. And one of those stuff, if you take a look in the calls that are happening, you will see that there is this authorize this call to this one /auth, and in this one, ChatGPT sends some request to Google, and you see that this page is powered by Google. So ChatGPT gives away the responsibility to identify user to Google. And then you do some stuff that is boxed in the Google world. In this case, what we can call authorization server. And depending on how much Google trusts you, it can be like sending an email, passkey, whatever. But eventually, if you keep following up the URLs, at this moment, this is the last call from Google, you will see that Google is sending back through a redirect back to a URL that ChatGPT in this case owns. If we check that this is the exact URL that Google redirects back, which is easier to see in this one, which is an OpenAI, so a ChatGPT URL. And this is exactly what it gets back. And then as everything worked, now I'm logged in. So as you see, there is a responsibility shift from a website to another website and coming back. And these are all places that a malicious actor can try to sneak into their own things and try to like bend this into a way that they can log in without going over this. However, this works, and this works globally. And there are a lot of things happening under the hood to make this secure, also interchangeable. And what I want to show you is a little bit of a glimpse of like how this works under the hood, not like super spec details because it's too big, but some introduction. So that is my aim for today. That being said, yeah, the topic is understanding OAuth and OIDC. Also, the difference between them is included. And yeah, you already see that it is about signing it with Google, which actually means we did an OIDC flow. And yeah, I'm Umut Benzer, currently working as an independent engineer. I was working at Auth0 for the last 8 years, and yeah, that's a topic that I believe I can bring now. But I am not affiliated with Auth0 in any way nowadays. All right, so let's start. So let's start with something that is pre-OAuth. By the way, OAuth stands for Open Authorization. Let's see the time before that. Maybe you remember it. Back in the day when Facebook was happening, like it was a thing of its own, you had this option to import your contacts from Gmail into Facebook. And when you click that button, Facebook asked for your Google username and password. If you were brave enough to give it to Facebook, Facebook was logging in on behalf of you and then fetching it through Google directly. And I think you start seeing the problem here. You were giving your the full access to your Google account, and you were trusting Facebook to only act on the things that it should be getting. But it was only your trust to Facebook. It wasn't a scope thing because you were giving your full access. And these were the times before there was a standard that was scoping the access. So, well, that was that. And this also had some problems, such as if you enabled an MFA, which sends a push notification or a code to your phone, then this whole give your password and it is enough would break immediately, and you needed to find some ways to circumvent it. And yeah, that is like not working seamlessly, let's say. But with OAuth, this whole thing is changing the shifting paradigm. That the idea with OAuth is to give a scoped access without sharing your password or your master way of authenticating. So you are giving access to, by scoped I mean read contacts in this example of Facebook, but you don't give access to your full account. So it can't read with anything else really. It can't reach your emails, for example. So that is the idea. And this example with OAuth is about, as you notice, is getting an information out, which is the contact information in this case. However, you can also think that maybe I want to only learn who the user is. That is also some sort of an information, but this time you are learning who the user is. So this is where this is shifting towards login, apart from getting an information. So yeah, that is also where these two things are pretty similar but also different at the same time part. So OAuth 2 is about authorization. Like with the previous example, you give access to contacts through this delegated authorization mechanism. That is OAuth 2. OpenID is built on top of OAuth 2. So it is adding an extra layer of standards. And in this case, the scope, the access you are getting is to who the user is in an interchangeable way. So in other words, I think it would be reasonable to say that OpenID Connect is built on top of OAuth 2 with the idea of making the identifying user as interchangeable as possible, while without inventing a whole new standard. So it is built on top of it. So I think the takeaway here is you get an access to a resource through an access token in the OAuth 2 world. And giving Facebook contacts of your Gmail account is a really good example. And it's all about permission. And in here, you get an ID token, not an access token. And this ID token is like it's sort of like showing your identity card from a distance without giving it. And it tells you who you are. So OpenID is about who you are, not like giving an access in this case. So that is the main difference between these two. So when we talk about login with Google or login with anything really, if it is following the OpenID standard, of course, it is about OpenID, it is about ID token, it's about the identity. So that is something that might be mixed up. All right, so this is another example that I like to give. If you go to a hotel and check in, they give you a hotel card, and with that one you can open your door. And this card won't work when your time is expired at the hotel, even you don't give the card back. So it has a access expiry built on top of it. Also, if you try other rooms, first of all, that would be really weird, but if you try it, it won't open the other doors. So it is also scoped to that room in particular. And the hotel won't give you the master key of like that opens all of the door. So this is exactly what OAuth 2 does. Master key here would be your password you shared, and the hotel key card would be an OAuth 2 token that is scoped to what you need to do. So yeah, I think that is pretty much the thing. All right. And OpenID we already told. In addition to this is being all about identity, this is a standard built on top of the previous standard OAuth 2. So it introduces some other endpoints and that kind of stuff, which I'm hoping to show in the demo. So I will not tell every single one of them in this slide and move on. And you will see some years over here, which are like when this standard is established. So these are all like specs that you can download and read and then implement or use a library or like a service like OAuth, of course. But these are all standards. That's what I'm trying to say. So if you go by the standard, it will work. That's the idea. Okay, so before I deep down into these flows, these OAuth to OIDC flows that eventually logged me into ChatGPT, I want to tell a couple of concepts that will be super helpful in our journey. And the most important one, I believe, in terms of security perspective at least, is front channel and back channel. So these sound quite fancy, but bear with me, these are quite simple. So front channel means anything that is going through a place where the user that is logged in can reach and maliciously modify if they want to, of course. For example, when I go in this ChatGPT example, when I press that login button, I am redirected to Google with this URL. This is built by when I press that button through some JavaScript or something probably. However, if I'm trying to explore things, I can construct my own and just send it to Google without coming from ChatGPT. So I can change any parameter here. Also, as you see, I can explore any parameter here. So I can pretty much play with it in the way I wish. So this is front channel. It is through browser and it is visible, loggable, local being I can get it. Also, it might be ending up in my system logs, Chrome history, or anything like that. So, well, you get the idea. So this is things that you shouldn't really put secrets, because that would be really bad to leak that secret. So you need to think that this is an insecure place and you need to prepare accordingly. And back channel is for example, if in this login, if ChatGPT is calling Google directly, which won't appear here, of course, because they are calling from their data center servers to Google servers, which is totally invisible to me, then that would be a back channel call. In that case, given that they are talking through an HTTPS, a secure mechanism, of course, it is going to be totally invisible to any third parties over the network. I will definitely not see it as a end user. And if you give a secret from one to other, only these two parties will know that secret, and I can't really steal that secret. So this is a secure mechanism that you should put your secret things. And that's the difference. One other thing I want to tell is in terms of concepts that is widely used in the OAuth world is the end user is a user. So in this ChatGPT example, that's me, and I'm using my browser, and I'm logging into something, and that is called a client that I'm logging in, and I'm logging in through an authorization server. In this case, the Google, and Google asking for permission or telling that I am me is Google. So Google is the authorization server here, acting as authorization server. And eventually they will tell who am I. But for example, in the Facebook example we were giving, if Google gives access to contacts, the contacts is the resource that I am getting access. So the place where I go and ask for contacts, that API call is done to the resource server. So whatever endpoint that is to get my contacts is the resource server that I am getting to. So these are concepts that are, I think, nice to know. Okay, I think we talked enough theory, and now we talk about more theory. I mean, this is at least theory with the nice drawings. So let's see what just happened when I do this ChatGPT. But in this case, instead of Google, I will use Auth0 as the authorization server. Guess why? So, and let's check what is happening under the hood. And OAuth 2 has different flows that eventually gives you access to a resource or your identity. There are many of them, and you should use the one that makes most sense for your flow. In this case, I'm going to explore one of the most famous ones, the ones that is widely used, which is an authorization code flow with a confidential client. It is okay if this doesn't, it's okay like this. This is just a name. Let's see it that way. So let's start. I'm the user and I click the sign in button, just like we did. And the web application, in this case, ChatGPT, sent to redirect me to a URL that is in the authorization server. This is equivalent to seeing that Google's page. And then Google, or in this case Auth0, showed me the login page. And then I needed to do things that are necessary to prove that I am I to the authorization server, Google, or O0 in this example. And finally, I convince the authorization server that I am a legitimate user. So this convincing is happening between me and the authorization server. ChatGPT or web application has no idea what is happening over there. That is by design totally invisible. And eventually, when the authorization server is convinced that I'm okay, I'm good, then it sends back to the web application to a previously decided callback URL. So this is like giving back the response to the web application. And this response will contain a temporary code that can be exchanged later to get a proper access or ID information. So what happens next is web application uses this code, and the web application also proves that they are them but not some random third-party stranger coming from the other part of the country. So they give a secret to prove it, plus the code that they received, and they ask authorization server to give them the proper access. And authorization server checks that this secret is indeed proving that this call is done by the web application ChatGPT, but not like some hacker. And then once authorization server is convinced, it sends back the tokens that are requested in the first place to web application. And web application now knows that through these tokens that I am this person proven by this ID token, and I have access to things that are in this access token. And then web application can use this access token to go to the resource. This is equivalent to getting the contacts from the Google by the access that is provided. I think this is okay for now if it is not fully clear. But one thing that is important is these are redirects that are happening on my browser. And these are things that I can read and change and play with it. So these are front channel. These are the things that shouldn't have any secret. However, in this case, the web application through its server directly called authorization server O0, sorry. So this is happening in the back channel. So this is secure. I think these colors or like where the transmission is happening is quite important. And we will now see what kind of verifications are happening under the hood. That's so everything is sort of checking that the previous step is done properly, so you can't cut everything and start with this and get a token. So that's the whole point of this. Okay, and there are many parameters that you send in every single part of these calls, and they are not to make it complicated. They are there because of a reason, because there was a problem, a vulnerability that is addressed with these ones. So there's a reason for them. That's what I'm trying to say. The authorized request is the first request when I click that login button and go to the authorization server. And in this one, you need to send these ones. The redirect URL is where you want to get back the response so that ChatGPT will get a response and process it and then eventually log me in. And as you can imagine, people can change anything they want here because I have access to it. I can build my own. So the redirect URL has to be pre-registered with authorization server so that you can't really put these random redirect URLs back. It cannot be anything. It has to be one of the allow listed ones beforehand when this whole thing is being set up. This is because we are doing the code flow, as I mentioned. This is saying that I want to get a code back, which I will exchange later. And these two are the following. So as I mentioned, I can build this URL of my own and then send it without clicking that button. And as the redirect URL is ChatGPT back, it will end up in ChatGPT back. Even ChatGPT didn't start it. State solves this. So you give a state that is a random generated string, and the state is sent you back in the callback. If they don't match, then you know that this is coming out of nowhere, not the one that you expect. It is something else, so you can discard the whole thing. So no one can like inject something that you didn't start. And nonce is similar to state. In this case, let's say that you have a token, but you have an ID token, but this ID token is reused from a previous session. Well, when you are going to the authorization request, you also give a random string again, a nonce, and the token that is issued back to you will contain these nonce in the token. If this nonce is not existent or different, then it would mean that this token, even if it is valid, it is not a result of the authorization request that you started. Maybe they minted one or like they stole one from the past and then they give it to you like you get. So with nonce, you can check that it is the result of what you started, but nothing else. And scope is about scoping the access, as we talked many times now. So in this case, we only want access to the OpenID, for example. I can ask for OpenID, then the email, and then the phone number, and then the Google contacts or whatever I want. But I should ask for the least amount of things, and I should get access to the least amount of things back. Of course, if you ask more, then you will see this consent screen. I'm sure you see it coming from Google, and it will list you what kind of access is requested over there. So asking for more doesn't just give you the access to everything when this is complete. The user will see it and user will need to approve it. So this is not like giving access just because you ask, but at least is showing your intentions of what you want to get. And the least you ask is better. One thing you should be asking, maybe you can ask for like in this flow here, why you not directly send access tokens back? Like what is the point of getting a code and then exchanging it? Isn't it like a unnecessary step? Would be a good question. And in this case, the thing is, if you send it back directly to the callback URL, it is going to be coming back to the end user directly. It's going to be visible. Let's see these URLs. If I would be sending back the ID tokens directly, it would be happening here as a part of this one. When I'm going back to from Google, when I'm going back to OpenID, OpenAI in this one, let me show it in a nicer way like this. In here, instead of a code, I would get the tokens directly. An access token, an ID token, logging in, so ID token in this case, it would be visible here directly. And that would mean that it is now in the browser and I can also see it. If it is done through the access, through a redirect URL with a question mark or a hashtag or things like that, it might be in the browser's history. It might be in some of the logs. So what I'm trying to say is this is visible to the end user and you don't want that. So the part of why there's a code is to make sure that the ID token is only going to be visible once without presenting it in the front channel. So only the server that's supposed to get it gets it. So that is the idea. And sending tokens directly, by the way, was a thing. It's called implicit flow. It is still in use, but it is insecure due to the reasons that I mentioned. But well, it was a spec and it is still a spec. So it is doable. In terms of logging in, definitely works, but it's not recommended because it is exposing things more than that. So now you know about the first one, the /authorize, where we go to Google. Now let's talk about the code exchange that is happening. Let me go back to the here. So now we talked about here, what we sent here. That's done. Now let's talk about here, what we sent here. So we get a code back, as you can see here. And this is this Google saying that, hey, there's this code. You can exchange this for an ID token to know who the user is. And this is valid for super short session. Use it as soon as possible. This is what it says. And now we will use it as soon as possible to get a proper ID token to eventually know who the user is. So let's now check what kind of things are happening now. And as you see, there's a demo coming right after this. All right. So first of all, we go to this token endpoint of OAuth 2, which is a standard. And in here, we need to send a couple of things. First of all, we need to tell that we are exchanging a code because there are other exchanges that might be happening. So we are setting up for what we are doing. And then we are sending the code that we want to exchange. In this case, the ChatGPT's backend would exchange this for a proper ID token that proves that I am I. And as you see, it is front channel, so the code itself is quite visible. We sent the redirect URL that we initially used one more time to make sure that it is still matching. And then we need to prove that we are the ChatGPT backend and not some random stranger. In case this code is exposed and then stolen, no one else should be able to exchange it and get an ID token, because it's all meant for ChatGPT, no one else. And to prove that I am ChatGPT, I'm putting a client secret that we previously agreed with the authentication server, in this case Auth0, a client secret. And I'm sending it back to prove that, hey, dear authorization server, I am me. Here's my secret. We agreed with this before, so I'm sending it so you know it's me. Now let's do the exchange. So this is like me convincing that I am the proper party. And finally, when the authorization server is convinced, then it will issue me the tokens that I asked for in the first place. For the OpenID, that would be an ID token. Okay. So let's see this in action. On the right hand side, you will see the back channel things that the server has access to. And on the left hand side, you will see the browser. Normally this is the part that you won't see. It is the one that is hidden, but as it's a demo, then we see everything, and I will rotate my secrets right after this session, of course. All right, let's start. This is the demo that I want to show, and this run code flow button is me clicking sign in with Google button in the ChatGPT example. It's the same thing. When we clicked it, what happens is my website of localhost 3000 sent me to the authorization server. As I mentioned, this demo is powered by Auth0, but it is the same standard, so it is like really the same thing. It sent me to authorization server, and let's check what kind of things are sent through front channel. Well, I want to log into this client, which is the application that I'm logging in, representing my website. I want to go back to this localhost 3000/callback endpoint, which is allowed listed before at the Auth0 dashboard, so it is allowed. I want to get a code back. I want to get an OpenID result back, so an ID token, and I want this token to contain the basic profile of the user as well as its email address. And I don't ask for more thing. I don't really need telephone number, for example. This is a random generated number, which is a state. And this is the nonce. So we expect this to be back in the callback URL. We expect this to be in the token. And this is an Auth0 thing. I want to skip any existing session and always see this login, so I can show the login box. So we redirected back to here, and in here I will log in with a quite secure username and a password. Just kidding. And when you log in, you come back. So before we explore here, let's see what happens here. Auth0, once authenticated, come back to the web page through the callback endpoint as we were expecting. And this contained a state, and this state is matching with what we sent, which is checked by the localhost 3000's implementation, so that we know that this is not coming out of blue. And then we also receive this code, which is also you can see in the URL bar over here, which is here, which is one use, which is short-lived, like minutes kind of short-lived. And now I need to exchange this through a mechanism, which is this exchange endpoint of OAuth to token in my Auth0 tenant, so that I can get a proper access, a proper URL. And for that, what I do is I say that I want to do a code exchange, and this is my code. And this is my redirect URL to give the same thing. It's a part of the standard. And I want to do it for this client, which is the same client, so that authorization server knows that it is matching. And this is the proof that I'm localhost 3000, because you gave me this secret in the past, and now I'm giving it back to you, which is normally a random string. And Auth0, when I call Auth0 with this, Auth0 gives me back this. Okay, you are good. Here is your token type, which I will not go into so much detail. this token is valid for this amount of time, and this is your scopes, and well, I give you two tokens. This is your ID token, this is your access token, and this is in this case there is no refresh token. I won't go into refresh tokens in this session. And then we get a token back, which we need to verify that it is a token that works, which I will explain later. But once we verify that this token is valid and cryptographically sound, then we can know that who the user is by exploring this token. And that token looks like this, which is quite unreadable. But if you parse it, you will see something like this. And by the way, this is a part of the standard. So regardless of who you connect to through OpenID Connect, it will follow this standard. So you can make it interchangeable. You don't need to re-implement it for Google, Facebook, whatever. And this is pretty much says that I am, where is my email? This is my email address, some basic profile information like this. My email is not verified, says the authorization server. Well, guess why? And it says that this is issued by this place, which is my tenant. And well, yeah, things like that. Like this is the user ID and that kind of stuff. So this is my proof, after cryptographically verified, of course, that this is the user. This is where I log in this user. So this is the whole flow. All right. I know this is too much, but well, now you see an end-to-end flow. Let's take a minute, calm down, and then I will put you more problems. One thing that you might be thinking is there is a exchange which involves client secret. I gave it because it was stored by backend. But what if there is no secret? Sorry, there is no backend that you can store a secret. Let me give you two examples. One is there is only a single page application with no backend, React Vue, something like that, running totally in my browser, serverless. There is no backend, and I can't put a secret into a single page application. No matter how much I try to hide it, it is in the computer of the client, and they will find a way to reverse engineer that. And the same thing goes for the phone. Regardless of how much you package your phone application, if you share that secret with every deployment to every customer in the whole world, it is not a place you can hide secrets. Someone will decompile it and get your secret. So long story short, you can't always store a secret, which breaks our previous flow where OAuth/token endpoint requires a secret to give you a codec. And there is a solution for it, which is called a PXE flow, which is standing for proof key for code exchange. Everyone says PXE, and I mean, I had to look it up what it stands for before this session, so no one really also knows it by heart. I mean, maybe everyone knows, but I don't. But it is called PXE, that I can say. And this is a slight modification of what we have seen, and this is meant to allow this flow to work, but without any secrets. And because of that, this is not a flow that I will explain from the very beginning, because it's the same thing. I will only explain the differences, which are shown by the yellow, by the way. We still click a sign in button, but in this case, what we are doing is in the front end application that can't keep the secrets, it creates a challenge, and a challenge is a long string. We will come back to how it is calculated. And to this authorized endpoint, in addition to everything else that we have been talking, it also puts a challenge, which is a string. And then the authorization server shows the login page, we log in, and then we come back with the code, nothing changes. And now we need to exchange this code to get the proper ID token. But we can't give a secret this time, because this is literally happening from the probably from the browser window directly from that running single page application. As we talked, there is no backend. So what do we do? In this case, we need to the point of this code exchange is this second part is, by the way, the whole point of having it is that we need to prove that the part that is asking for ID token is who should get it. So we need to prove that we are the correct person, the correct system, and we need to identify ourselves in a way that cannot be broken to the authorization server that we are not a random stranger. That is the whole reason of why we need this exchange part. And if we can't give a secret, which would be like quite easy, then what we can do is a cryptographic replacement of the same thing. So we sent the code like the past, but this time we also sent a code verifier. And this code verifier should be only known by us because it is a cryptographic way, a non-reversible way of proving that code challenge was created by us. So in other words, if this challenge and this code verifier are the part of the same thing, no one else can create it because it is cryptographically very hard to impossible to create it. Maybe with quantum computers, I don't know, but yeah, not like a normal flow can do it. Okay, and then the rest is the same. We once verify that OAuth0 this is the correct party. It gives an ID token and access token. But how does this code verifier and code challenge can work then? We said like it is cryptographically, but I think we should see the concrete how it is calculated. Well, I have a slide for that. So let's remember that we are first sending the challenge and we are sending the verifier when we are doing the token exchange. So the challenge, a verifier is a random string of some long string. That is it, some random string. And the challenge is SHA-256 hashed and also packaged version of the same string. That's pretty much it. So you first send the challenge, which is when you send authorize, hey, this is the SHA-256 result, the hashed result of this string. And when you are doing the code exchange, you send the original value. And the authorization server does the exact same formula, gets this verifier and then runs the same algorithm, and it checks if the challenge is matching between the previously provided one and the one it calculated. As SHA-256 is not something that you can reverse engineer, reverse back, it's one-way street. And as you are using a really long thing, long randomness, so it is highly unlikely that that would be in a rainbow table and it is calculated in the past. You can't really figure it out and find the correct value as a third party. So that is like how you verify that it is you, by giving the result first and then the value that gets into that result later. And yeah, that is pretty much it. This is how you know that it is it. Well, as you notice, there was a second demo in the same page, this one, and now let's do it. And that would be the last demo. Let's clear the screen and let's click this button. So again, we went to the OAuth0 with the same part, with only difference being these two. This is the challenge and this is the algorithm that provided that challenge, which is SHA-256. This is the standard way of saying it in the OAuth world. And then I will also do this login one more time. And we come back. So if we check, this part is pretty much the same, no changes. But now we need to get the token. This is the part that's changed. So in addition to the same things like grant type and code and that kind of stuff, you won't see a client secret here. That is the biggest difference. Instead, you will see the code verifier. So if you run this algorithm of SHA-256 of this and then the base 64 as in the algorithm, you will end up with this. This is what OAuth0 does as the authorization server in this example, and sees that it is a match, and then it trusts that this token endpoint call is done by the same party, and then it just issues the ID token back. The rest is the same, nothing is different over here. The takeaway is, if you can't keep secrets, you still have ways to do it, and this is like why this is invented in the first place. And the reason I showed these two is these are the most popular ones. So I think if you want to know one, I think, or two, these are the ones that matters the most. But there's always a but. Let's talk about this random really long token. Actually, let me copy and paste it to somewhere that is showing it nicer. jwt.io is a really nice way to visualize your tokens. All right, so you get a token like this, but I can also give it directly to the ChatGPT if I find the proper endpoint send mechanism. Giving this random string doesn't really prove that it is a legitimate one. I can mint one myself, like I can just do it. Even in this website, you can mint your own ones. How do we know that this is really coming from the place that we trust? This is the last step of the whole trust chain. So let's check it. Let's first check what kind of things that are in this long string. You will see it is dot separated into three pieces, the header, the payload, and the signature, which are also nicely color coded for easily seeing it. And the first part, the header part, tells what kind of algorithm and what kind of key is used to sign this whole key. So a JWT token is a signed token, which means it is signed by a private key of a party, and the public key of this party is exposed publicly on the internet. You can go and get a public key, and then when you verify the and then you can verify cryptographically that this string is created by that private key by using the public key, which is everyone's access, and then they end up with the same signature. So this is a way to say that only the part that has that private key can issue this token. So this is a way of doing this public private key signature. Anyways, so header says what kind of algorithms and what key is used. The payload is the actual part. The actual part meaning this part of like actually tells who the user is. And the signature tells that the payload is not touched because when you sign this, the signature should match to what the payload is generating for. So this is like the part that we can check using the public key. All right. So okay, so if you check this, you will see a key ID named this in the header part. And this is what this saying is, this whole token is signed by using this key. But what is this key? So in the very beginning of when me writing this application, I put my tenant name of Auth0 as the trusted body. And there is this concept of well-known URLs on the in the standard, and this jux.json is one of the well-known endpoints, and it is always at this location of the trusted body. So this is a URL that you can build only by knowing who you are trusting to, and this lists some cryptographic things. And if I search for that key ID, I will see that one of these keys in this array, this one that I'm highlighting in particular, by the way, this is, as I mentioned, totally public and you can cache it for a really long time. This key is used to sign that token. There are other keys, but they are not used. This one is used. It used this algorithm, and there is a reference to the signatures, the public part of the signatures. So by using this information, you can check if the rest of the token is cryptographically sound. This is like how you know that it is working without going and asking to Auth0. And that's the point, right? The public key, it is publicly available. You can cache it for a really long time. You have an ID token that you need to verify authenticity, or an access token, of course. But you don't need to ask Auth0 or the authorization server every single time, hey, this key is valid, is token is valid, is token is valid. So you save a lot of network calls. So this scales really nice. With this one, you can validate millions of tokens without really going and doing one single network call. So the verification is isolated from the rest of the thing. And yeah, these are the most popular ones that are in the payload of the token. The issuer is who issued this token, which I should be checking and see that it is the correct tenant, not like the neighbor tenant of the Auth0, because, well, it has to be me, right? Who it's meant to, when it will expire, and the nonce value in the token. So yeah, let's go back to that. We didn't explore that. So this is the nonce value that is in the token, and that nonce value is the one that I sent at the very beginning of when that login button is clicked. So I know that this token is a result of what I created, not something random. And that's pretty much it for these basic flows. There are way more complicated flows for reasons, which I put the names of some of them. For example, if you don't want to send a client secret, then you can sign a private, by using your private key, you can create a signed JWT as your secret. You may want to hide all of these /authorized parameters that we have been publicly seeing under some different mechanism, a different flow of pushed authorization request, and the other one, par and jar, what we call. The tokens we receive, these ones, are bearer tokens, and the bearer token means it is valid until it is expired through that expired time. So if you got it stolen, whoever stole it can use it. There is no security behind it. But the depop is demonstrating proof of possession. It stands for is a type of token which is bound to the client that received it in the first place through, again, some other cryptographic measures. So even this is stolen, no other than that client can use it. So it is a bit more secure version of it. And there is a flow called, which I really like, this one, SIBA. Client initiated backchannel authentication, really cool names. And this is for things like you are calling the call center, or you are on your TV, and then they send you a way of logging in. You log in on your device, and then when you complete your login on your device, your TV logs in, or your call center call continues. So the part where you log in, and the part where you type your password kind of things, and the device that you logged in are separate, but it is the same login flow. So this is another flow, and there are many others, of course. All right, so in this session, I wanted to show you two flows of OAuth OIDC, the most valuable ones, in my opinion, if you want to learn only two. And I'm hoping that you know what happens now a little bit more when you click that button, and why we have so many flows, so many exchanges, so many parameters, because they all have a reason. They are trying to solve a particular reason to make this whole thing secure and also exchangeable. So thank you again.
Yeah, Umut, thanks a lot for a really deep dive in this topic. And Atakan, maybe you could start with your questions, and then I can ask mine.
Yeah, it was very like in-depth explanation of the OAuth, also like the Pixie flow and everything. I just wanted to ask, like, what do you still think about this ongoing split between like between like the OIDC flows and the SAML in the case of authentication? Because like, I mean, even though OAuth and OICD is like around for a long time, there are still like providers or like Cloudflare or something that still accepts SAML. Do you think like these things will be eventually standardized down the line, or
I'm not sure if SAML will ever go away, because it is quite popular in the enterprise world, to my knowledge. And as there are systems that are only looking for SAML, there are enterprises that are providing SAML. So it is still pretty much in use. It is my personal take is SAML is quite complicated when it is compared with OAuth, and this complication makes it harder to understand and also verify. And unfortunately, there were security incidents that are publicly visible in the reports that are related, for example, how a SAML token is validated to make sure that it is cryptographically sound. Because, by the way, I'm not like super pro on the SAML definitely, but to my understanding at least, in the SAML tokens, you can verify parts of it only by giving a signature for that part, or you can sign different parts with different signatures. And sometimes you can bend this, because if the verification logic is wrong, you can insert one more claim over there and it totally slips through this verification chain because it is in this weird place. And this kind of things happen. And this is all because the standards are complicated, that implementation may not be always correct. So if I would have a magic wand, I would like do OAuth to everything, but it is of course not happening. And yeah, SAML has its own uses. That's like what I can say.
Yeah. Yeah, thank you very much. I just want to know your thoughts about it.
Yeah, I have a couple of questions. The first question is that, like, as you described, so when you are doing this Google sign-in, right? So backend server as a state, it stores the token or the user's email that next time it remembers. Is it like token or the user email or some like identification as a stateful part that server understand that, okay, this user I have already now that logged in before.
Are we talking about ChatGPT remembering me after refresh
In
or
general.
Google remembering me after refresh?
Yeah, I mean, in general, for example, let's say first for like a web application asks me that, okay, I have to sign in with my Google, and then I just enter the application, and next time, let's say tomorrow, when I want to access it, so how this server understand that it's still me, not the other user.
Okay, so while it might be different for implementations, what I can like think as the most common approach is in this case, ChatGPT or like the, let's say, the client will start its own session once it knows who the user is. And depending on the implementation, it might be as simple as having a cookie that is HTTP only, so that it is not like really accessible by the browser itself, but sent always to the backend. And through that session value, it can put like who the user is in the database. Something like that could be enough to know who the user is.
Yeah.
And for the authorization server, it might be the same. For example, Google already knew who am I, so I just clicked a button. I didn't put my password in this case, because Google has its own session with the Google itself, so it can show me who am I. And it will also have its own session in the way that they do. The way I explain with the cookie is like a quite straightforward one. It might be way more complicated then, but I think the bottom line is they will create their own session once they identify who the user is.
Yeah, but this, for example, in Apple, like when you are doing this authentication, it usually shows this private some emails that like it's actually not my actual email, but kind of the generated one.
Ah, yeah.
Yeah, yeah.
In that case, with the Apple case, we need to follow the full flow, but if I'm imagining it through OIDC, I can answer something like that. You click that button, login with, let's say, Google, because I don't know like the OpenID and the Apple, so it might be a wrong example, and we go back to Google. Once we are at Google, it is all about what Google gives me back. So given that Google had a functionality of hide my email, I can pick it there and then do things, and then finally click continue in the Google side. And once I do it, if Google decides to issue an ID token that is saying my email address is some different email address, but signs it with Google's private keys and everything, given that ChatGPT in our first example trusting Google, that the ID token is going to come is like how they identify me. Through this, I can log in with a different hide me email back. Eventually, from ChatGPT's perspective, ID token has an information, and Google puts something else because they have a feature of it.
So basically, there is the ID in the ID token, right?
Yeah, ID token contains email, user ID, and depending on what you ask, there is a list in the spec. You can even ask for like telephone number, the home address. Of course, the provider may not know it and answer back, but there is a full list of things that you can even ask, work address, fax number, I guess. So it's a part of the standard.
Yeah, but let's say, what if there's like this Google and other applications for the GitHub, for example, how can I tie all of these like to my single web application that, for example, whenever like I choose like either Google or I don't know Gmail or I don't know Facebook, so all knows that like this is this user.
There is no easy way to do it. So let's say you have like this login with Google plus GitHub
Yeah.
in your application, and user chose one and then the other one the next day.
Yeah.
By the way, in the modern websites, I see this last used banner in the
Yeah.
login ones, which is a client thing. Like there's literally probably a local storage or cookie that says like this was used in this device last.
Yeah.
But if you log in with these two different ones, eventually you will get two different user IDs from two different providers with email might be the same if they are sharing the correct email, of course. But on the other hand, for you, these are two different users in your application. If you want to link them into a single user that your website represents, then you need to do it yourself. And there is not like a universal ID that you can use. You need to figure it out. One of the approaches you might do is to check if the email addresses are the same and then just link them. However, it has security problems with that you need to be super careful. For example, not every provider has to make sure that email is indeed the correct email. Like, for example, I'm not saying this is the case, but I have a provider and I'm issuing tokens, but I don't do email verification. So I can just like log in as elnur at something.com without verifying that it's your email address, get an ID token and get a link to your existing account in your website. And now without doing anything, just by registering, I'm you. So this is a security problem. So you need to make sure that it is enough only to check email from different ID providers because they may not be that strict. Also, for example, Google Workspaces issues tokens. The enterprise Google Workspaces also provides ID tokens. And for example, you need to make sure that if a token coming from there and you can distinguish from the Google's its own like the regular one. So what I'm trying to say is you need to make sure that all of these cases are handled and there's no one global way of doing it.
And my last question is that let's say I have already logged in with my Google in my laptop, and let's say there's a bad person, like bad actor, like someone hacked my account and tries to use my same Google account to access my profile, or maybe like someone in my own like local area, let's say my mom like wants to access like with my phone. How this race condition works, for example, if I'm in the still session, like when someone access it, like is it like expire my session and refresh the one access like latest, or like how this process works?
This is totally dependent on that website's security practices and implementation, and this is not really related with the OAuth in this one. One thing I see is there are some very strict, mostly banking applications that allow only one single session ever. And I see two variants of it. One is rejecting every other login until one is logged out or expired. And the other one kicks out everyone old and only keeps the new one. Which is a bit weird because if someone steals your identity, then you are kicked out. But the other one is also dangerous because if they hacked you and now you are trying to sign in, you will be rejected. So it's not like ideal. But this is one thing, like you can allow only one session. That's perfectly fine, maybe a little bit weird, but definitely doable. One thing I see in most of the websites is they list your active sessions. Google has it, like accounts.google.com, if I remembered correctly, and you can see where you logged in, when, and the last time. But it is like their decision to do it that way, and usually companies have some sort of a trust mechanism, and if they think that you are a bit of a fishy logging in, like right now here and then connecting to VPN 5 seconds later and coming from like the other part of the world, there are calculations. For example, it can think that this is geographically impossible to travel that amount of time in this short time, and then maybe I should ask for MFA, even that I don't usually do. But this is all up to that company, their decisions, their risk factor. Maybe one other thing, for example, you have seen is normally your banking application, you just log in with your password, but if you try to make a transfer, Then they ask for a authentication, a further one,
Yeah.
which is called step-up authentication. You give access to the regular stuff, but if you, for example, try to change your password, you ask for something more, like, I don't know, an SMS code or something like that.
Yeah,
So,
I have
but
seen.
again, these are not a part of the standard. This is like something else.
Yeah. All right, so thanks a lot for really interesting and really deep dive in the topic. I hope it will be useful and helpful for others. So guys, it was end of DevStandup episode 31. And today our guest speaker was Umut. If you now or would like to be our next guest speaker, sharing your experience and knowledge, fill the form under the description of this video and our team will contact you and you can be our next guest speaker. So apart from that, have a great day guys and see you in our next DevStandup session. Bye-bye.
Thank you so much.
Yeah, thank you.